Section 5.1, our objective today is I can apply the definition of a parallelogram and theorems about the properties of parallelograms. So let's start out with the definition. So a parallelogram is a quadrilateral in other words, of four-sided figures with both pairs of opposite sides parallel. Okay, so if I have quadrilateral A, B, C, D. And if this is a parallelogram, then AB has to be parallel to DC because those are opposite sides. So this side is parallel to this side. And AD must be parallel to BC. So, if we are told we have a parallelogram, then we know for sure that we have two pairs of lines that are parallel to each other. So we know that segment AB is parallel to segment DC, and we know segment AD is parallel to segment BC. Okay, so just by telling us we have a parallelogram, we know we have two pairs of parallel sides. Okay, then we have the theorems. So our first theorem says that opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram are congruent. I also forgot to tell you the symbol for parallelogram, and so instead of writing out the word parallelogram because it's very long, we just do a quadrilateral. So we would say this is parallelogram A, B, C, D. Okay, so again, our first theorem is the opposite sides of a parallelogram are congruent. So if I have a parallelogram A, B, C, D, so I not only know that AB is parallel to DC and AD is parallel to BC, I also know that AB is congruent to DC and that AD is congruent to BC. So I know that segment AD is congruent to segment BC and segment AB is congruent to segment DC. Okay, so opposite sides are congruent. So this side is congruent to this side is congruent to that side. So not only are opposite sides parallel to each other, they are congruent to each other. Okay. All right, and then our second theorem says that opposite angles of a parallelogram are congruent. Okay, so again, if I have my parallelogram A, B, C, D, then this theorem says that angle A must be congruent to angle C, because those are the opposite angles, and that angle D must be congruent to angle B. It's supposed to be a B. So opposite angles are congruent. Okay? And then the third theorem says the diagonals of a parallelogram bisect each other. Okay, so again, if I have parallelogram A, B, C, D, and I draw in diagonals, so diagonals go to opposite vertices, okay, then that creates a point O. And so O is going to be a midpoint of AC, and so I know that AO is congruent to OC, and I know that DO is congruent to OB, because it says the diagonals bisect each other. So segment BD is a bisector of segment AC, and segment AC is a bisector of segment DB. Okay, so that gives me congruent parts. Okay, right? So let's look at a couple of examples. Okay, so I have parallelogram RSPQ with diagonal PR and diagonal QS that intersect at point X, and this is angle 1, 2, and angle 3. Okay, so if I know PQRS is a parallelogram, then number 1, if PS, length of PS is 5, then length of QR equals, well, PS is this side of the parallelogram, and we know that opposite sides have to be congruent, so length of QR must also be 5. Okay, number 2, if length of PR equals 20, then length of PX has to equal what? Okay, so PR is this segment, and we know that the theorem says that the diagonals of a parallelogram bisect each other, so we know that X is a midpoint of PR, so therefore PX is half of 20, or 10. Okay, then number 3, if measure of angle QPS is equal to 125 degrees, then measure of angle QRS equals what? And measure of angle PQR equals measure of angle PSR, which equals what value? Okay, well, let's see where we are. QPS is this angle, and so we know that is 125 degrees. And so we know that opposite angles are congruent, so that means this one must also be 125. So QRS must be 125 degrees. Okay. Then PQR, which is this one, and PSR, which is this one, have to be congruent because they're opposite angles. And we know this is a quadrilateral, so we know that the measure of the interior angles is 360. And we know that this angle and this angle are both 125, so that's 250. So if I subtract 250 from 360, whoops, we get 110. So we need to divide that 110 into 2 equal parts. So that's 55. So that means this angle, PQR, and angle PSR both have to measure 55 degrees. Okay, and number 4, if measure of angle 1 equals 27 and measure of angle 2 equals 30, then measure of angle 3 has to equal what? Okay, so this is 27 and this is 30. Okay, then measure of angle 3 also has to be 27. Okay, and that's because angle 1 is made up of this line and this line, and angle 3 is made up of this line and that line. And we know this is parallel to this, and we know then that QS is a transversal. So angle 1 and angle 3 are alternate interior angles, so they have to be congruent. And angle PSR, okay, PSR, which is this whole angle right here, has to be the same as this one, which is 57. So PSR has to be 57. Okay. Example 2. If I have this picture, and this is a parallelogram, this is 7, this is A, this is B, this is 12, this is X, this is Y, and this is 112. Okay, so applying the properties, I know that A has to be 12 because opposite sides of a parallelogram are congruent, and therefore B has to be 7 because opposite sides of a parallelogram are congruent. I also know that angle X must be 112 degrees because opposite angles are congruent. And I know that this is parallel to this, and so angle X and angle Y are same side interior angles. They're same side interior angles, so therefore they have to be supplementary. So this is 112. Then 180 minus 112 is 68. So measure of angle Y has to be 68. Okay? So this angle is 68 degrees, which means then that this angle is also 68 degrees because opposite angles are congruent. Okay? And let's do one more, number 3. Okay, if I have this picture where this is 10, this is B, and I have these diagonals where this is 10, this is x, this is y. This angle is 33 degrees, this angle is 62 degrees, and this segment is A. Okay, and this is y degrees, so we're talking about this angle here and this angle, okay? So, so for A, we know A must be 10 because the diagonals of a parallelogram bisect each other. So this has to be a midpoint. So if this is 10, then this also has to be 10. So A is 10. Then B. B has to be 10 because opposite sides of a parallelogram are congruent. So if this is 10, then that has to be 10. Okay. Then if this angle is 62 degrees, then this angle must be 62 degrees. Okay. Because this side is parallel to this side, and this would be a transversal, so this and this would be alternate interior angles. Okay. And let's see, we know then that this is an isosceles triangle because this side is congruent to this side. So that means that angle X must be congruent to angle Y. And so we know that that the angles of a triangle add up to 180 degrees. So if we subtract 62 from that, we get 118. And if we take 118 and divide it by 2, then we know angle X must be 59 degrees and angle Y also has to be 59 degrees.